Hello, we're working with probabilities again, and we have a word problem here, working with political science and demographics, trying to predict voter behavior. In some fictional state N, we've got racial demographics distributed such that 3% of the state is Asian, 12% is Latino or Latina, 25% is Black, and 60% is white. In the last election, Democrats received 45% of the white vote, 72% of the Black vote, 67% of Latina, and 52% of Asian. Republicans received 52% of the white vote, 25% of Black vote, 32% of the Latino vote, and 46% of Asian, while third parties got 3%, 3%, 1%, and 2% respectively. And so we're going to use last election as a general trend, and assuming voters aren't going to switch parties, we want to see what the probabilities are that a certain voter will vote a certain way, or that given a party affiliation, that a certain voter will belong to one of these racial demographics. And so one of the first things we need to do in our first half here is to draw this tree diagram and a two-way table. And so we've got different racial groups in our society, right? And we know all of the percentages here. We've got 12%, 60%, 25%, 3%. And so just starting from the largest to the smallest, we've got 0.6 is white, we've got 0.25 is Black, 0.12 is Latin, and 0.03 is Asian. And in those groups, we know some voter behavior from last time. And so let's split this tree diagram up one more branch. Among the white voters, we had 45% Democrat, 0.45 for the Democrat, and then we had 52%. Republicans received 52%, 0.52 for R, and then for T, we've got 3%, or just a complement for Republicans and Democrats. This sums up to 97% of the vote, and then 0.03 for the last group there. Among the Black voters, we had Democrat affiliation in 72% of cases, so 0.72 for Democrat. Republican received 25% of that racial demographic vote. And then third parties received, again, a complement of 72 and 25 is going to be 3% or 0.03 for the T, or third party. Among the Latin voters, the Latino, Latina, Democrats received 67%, 0.67 for D, and then R gets 32% or 0.32, and then T gets the remainder. 67 and 32 add up to 99, and so the remainder for the T party, or the third party, is 1%. And then among Asian voters, the Democrats received 52%. The Republicans received 46%. And the remainder here, 46 and 52, is 98, so 0.02 for T. So we can make a two-way table here. We'll put racial categories across the top. Again, just organizing from the largest racial group to the smallest. W, B, L, and A. And then we can put party affiliation along the vertical axis here. We've got D, R, and T for third party. Right, so we know that among white voters, we've got Democratic voters of 0.45. And we want this column to add up to 1. We'll want the percentages here all to add up to 1. White voters are 25, Republican voters are 52%, and independent or third-party voters are 3%. Same thing for the Black demographic. We're just looking at the bottom values of our tree diagram here, 0.72, 0.25, 0.01, and 0.52, 0.46, 0.02. Okay, so that's our tree diagram and our two-way table. Now let's start looking at some probabilities. We can calculate some probabilities. And so the simplest ones are just going to be the probability that a certain voter belongs to a certain race or demographic. And we know those from the percentages in the population. So if 60% of the voters are in the white group, then the probability that a voter is white will be 0.6, just their share of the racial split in the demographic of the population. Similarly, the probability that a given voter is black is just their share of the population, 0.25, and on down the line, 0.12. Probability of Asian is 0.03. Those are the simple ones. And so we can move along from there. How about the probability of these different party affiliations? Well, the probability that a certain voter, any given voter, will be Democratic is going to be the intersection of these two values. We need to take all the white Democratic voters plus all of the black Democratic voters plus the Latino Democratic voters and the Asian Democratic voters. And so that's going to be the sum of the probability that will have both white and Democrat, black and Democrat, Latin and Democrat, Asian and Democrat. And so we can write the probability of the intersections, the sum of the intersections here. So the intersection is basically like an and you might also see a dot there. You have dot be your intersection be. Probability of L and D plus the probability of A and D. And so this is going to be multiplying 0.6 times 0.45 and on down the line. 0.25 times 0.72. 0.12 times 0.67. And finally 0.03 times 0.52. Or our probability of a given voter, any random voter being Democratic, or having voted for Democrats in the last election anyway, is 0.546. So 54% of all the population, all the voters, 54.6% voted Democratic. And then we can use that same method to find the probability that a voter will be Republican without drawing it all out. Again, it's 0.6 times 0.52 plus 0.25 times 0.25 plus 0.12 times 0.32 plus 0.03 times 0.46 or 0.427. And finally, the probability that any random voter will have voted for the third party, again, is the sum of the products on our t value or our tree diagram there. 0.027 or roughly 3%. Again, this one is just a complement of the sum of these two. All of those add up to 100% of the voters. And so now let's take a look at some conditional probabilities. So if we know that a voter voted for a specific party, what's the likelihood then that the voter will belong to a racial category? Or if we know that the voter belongs to a racial category, what then is the likelihood that they'll have voted for a specific party? That's the easy one to figure out. So the probability that the voter voted for Republican, given that the voter is white, right? So we know the voter is white, and the probability that he or she voted for Republican is 0.52, which is equal to the probability of the intersection of white and Republican divided by the probability of 0.6 times 0.52 divided by 0.6. Those cancel out, we get 0.52. And so let's figure out then what is the probability that a voter is white given that they voted Republican. Well, this is the probability of the intersection of white and Republican divided by the probability of Republican. And so we found out the probability of Republican here, so we can't do that simple skip a step and shortcut to find this probability. This is going to be different. Remember in a previous video we showed that when we switch the givens and the conditions there, those probabilities actually change. And so the probability that the person is white and they voted Republican will stay the same. That's 0.6 times 0.52. But the probability of Republican is different from the probability of being white. And so we've got 0.427 on the bottom here. And this is equal to 0.731. And so then this 0.731, this formula is just the simple version. We could also use Bayes' formula, which says that the probability of white given Republican is equal to the probability of Republican given white times the probability of being white divided by that same value, probability of Republican given white times the probability of being white plus the probability of Republican given white complement times probability of white complement. And let's take a look at another example to illustrate this point here. How about the probability of Democrat given that a person is Latino? And we know that already. Democrat and Latino here is 0.67, which again is the probability of Democrat and Latino divided by it's 0.12 times 0.67 divided by 0.12, so we get just 0.67 there. And so let's then figure out the flip side of that, the opposite, the probability that a person is Latino given that they're a Democrat. Well, this is equal to the probability of the union, both Latino and Democrat, divided by the probability of Democrat, which equals Latino and Democrat. We got 0.12 times 0.67. Probability of Democrat, 0.546. And this is equal to 0.147. And so then all of this is also equal to the probability of, again, using Bayes' theorem, we're going to switch these two. The probability P of Democrat and Latino times the probability of Latino divided by that same thing, probability of the intersection times the probability of Latino plus their complements. And so we've got probability of the intersection of Democrat and starting with the other racial categories. This is part of L complement here. If we had W complement, then W complement is Black, Latina, and Asian. Latina complement is W, B, and A. And then we're going to add to that same thing, the same pattern with the other racial groups. P of D and B times P of B. And finally, P of D and A times P of A. And so that's Bayes' theorem, and it just gives us another way, given if we have access to different data, right? We can solve this equation using what I think is the simplified term, which is just that intersection divided by the population of those voters. Or we can use Bayes' theorem, which is slightly more involved, I suppose. But these probabilities, Bayes' theorem, and conditional probabilities are incredibly important in political science and when trying to predict election results, right? So we can see that although the white voters, right, they have the largest group numbers-wise, their affiliation with the Republican Party, their higher affiliation in the Republican Party does not in fact give the Republican Party a majority in this state, because although the other three minority groups don't have a population as large as the white group, their affiliation with the Democratic Party as compared to their affiliation with the Republican Party gives the Democratic Party a majority or higher likelihood of success. And so conditional probabilities are actually quite important and practical, and so we'll continue looking at some more examples of these in future videos. Thank you.